Hello. Mm, mm. We'll be starting at 8 p.m. You can download the worksheets in the bio, link in the bio. Hello, Xiaoning. You guys here can take a look at our worksheets. Hi. Hi, Duncan. You guys here can take a look at our worksheets first. Try them out. be starting at 8. Hello. There's no Kahoot today. Okay, we'll be starting soon. Yep, just now the TikTok live is for English, primary 6 English. Now it's on Sec 1 Math. Okay. I see. Bye-bye. You can join for tomorrow live. It'll be on primary 6 Math. Okay. So those who are here, you can try the Step 1 Math work. You can get the worksheets in our bio, the link. Oh, thank you. Okay, if you're Step 1, you can try this question. Yep. You learn on primes, factors, and multiples already, right? Okay. Do try question 1A, then those who are done, send in your answers. Write 2,904 as a product of its prime factors. So you have to understand what are prime factors. Meaning you have to leave them in factors whereby all the factors are prime numbers. Anyone done with question 1A? This is for Set 1 Math. Can you hear me? This is for Set 1 Math. Can everyone hear me now? Okay, anyone done with question 1A? Okay, can you send in your answers? What do you get for question 1A? What are the prime factors of 2,904? So we have 2,904. So to prime factorize, we keep dividing by prime numbers. Okay. So you can tell that it ends with 4, so it must be an even number. So for even number, we can divide by 2. Can you hear me? about the rest? Can you hear me? Okay, so we divide by 2. So 2,904, when we divide by 2, we will get 1,452. Okay, so it's still an even number, so we still can continue divide by 2. When we divide by 2, we get 726. Divide by 2 again, we get 363. So now we don't have any more even number. Can't hear me? Yep, you can only divide by prime numbers. Hmm? Can you hear me? Do you on the volume? Because I can hear myself actually. Hmm. That's so weird. Okay, let me see. Can you? Okay, so 363. Okay, thank you, Natalie. So 363 we can divide by 3 because when you take 3 plus 6 plus 3, it's equals to 12. So 12 can be divided by 3, so 363 can be divided by 3. So when we divide by 3, we'll get 121. Okay, so 121 can be divided by 11. You get 11. And you divide 11 again, you get 1. So we stop when we have 1 at the bottom. Okay? So with this, you can see that actually what we are dividing by all here will be the prime numbers. Okay, that's why it's prime factors. So how do we leave them in prime factors? 2,904 is equals to 2 times, 2 to the power of 1. 2 appeared 3 times. So 2 to the power of 3 times 3 appeared 1 time, so 3 to the power of 1 times 11. 11 appeared 2 times. So 11 to the power of 2. No, I'm a right-hander. Okay? So you can leave your answer in this manner, in index notation. Part B. Find the smallest positive integer value of k such that 2,904k is a perfect cube. Can you hear now? Actually, I'm talking to the mic itself already. And I'm talking quite loud. Maybe you want to change your device and try? Or from another handphone, you see if it's louder. Mm-hmm. So you want 2,904k to be a perfect cube. So what is a perfect cube? The power or index would be, it needs to be multiple of 3. 99 is correct. Well done. Guess and check. No, you don't need guess and check here. Because 2904K, you want it to be perfect cube means you want the powers to be multiples of 3, right? And then you already have the prime factorization of 2904. So if you want it to be, you can see that you're multiplying with K, right? So you want the powers to be greater than whatever that is here or at least the same. So we have base 2. We want the power to be multiple of 3. So since the base 2 already has multiple of 3, we can let it be. We just leave it. Then times base 3. The power is 1. It's not multiple of 3. We want it to be multiples of 3. Okay? So the nearest would be power 3. Then times the base 11, it's power 2. It's also not multiple of 3, so we want it to be multiples of 3. Okay? We go to the nearest multiple of 3 because we want the smallest positive integer value of k. Okay? And we have the prime factorization of 2904, which is 2 to the power of 3 times 3 to the power of 1 times 11 to the power of 2. So the difference in the power here would be the value of k. Okay? So this 2 to the power of 3 is already at this 2904, so we do not need any multiples of 2 for my k. Then we take minus the power here, the base is 3. So the power 3 minus power 1, we have power 2. Okay, so my k must have 3 to the power of 2. And then for 11, power 3 minus power 2 is power 1. So I also need the base 11. So 11 to the power of 1. 99 is correct. Okay, so 3 squared times 11, you will get 99. Can? Or you can just write 3. Don't need the power 1. If it's power 1, you can don't write also. It's the same thing. Okay, those who are done with question 1b can move on to question 1c. No, we are working on G3. Okay, I see correct answers. Part C, the highest common factor and the lowest common multiple of two numbers are 10 and 120 respectively. And I tell you the two numbers are not 10 and 120. So find the two numbers. So what we can do is we can prime factorize the two numbers first. So 10 is equals to 2 times 5. So this is quite straightforward for 10, so we don't have to do the branches method or the long division method. There is no lowest common factor. It's called lowest common multiple. Okay. Highest common factor means let's say you have two numbers. What is the greatest number that can be exactly divisible by? Then for the lowest common multiple, it will be what is the smallest common multiple between the two numbers. Okay. So 120, we can keep dividing this 120 to find the prime factorization. So 120 is an even number. We can divide by 2. We get 60. 60 divided by 2 is 30. 30 divided by 2, we get 15. 15 can be divided by 3. We get 5. And then 5 divided by 5, we get 1. Okay, so 2 to the power of 3 times 3 times 5. Okay, so what are the two numbers? Let's say we let the two numbers be A and B. Okay, so this is number 10 is my HCF and 120 is my LCM. So both numbers must have my HCF in order for it to be the highest common factor. So it must have at least 2 times 5 for both of them. Okay, then we look at the LCM. The LCM must come from somewhere. So either of the number must have 2 to the power of 3. So let's say I make my B to have to be 2 to the power of 3. So my LCM comes from B for this 2 to the power of 3. Okay, LCM also has 5, so my power of 5 can only be 1 because my LCM is 5 to the power of 1. Okay, so now I'm left with this factor, prime factor of 3. Oops. I'm left with this prime factor of 3, and they tell you that the two numbers cannot be 10 and 120. So my A cannot be 2 times 5 because that's my highest common factor, and my B cannot be 2 cubed times 5 times 3 because it will be my LCM, which is 120. So therefore, my LCM 3 must come from somewhere. It cannot be at B, so I have to put it at A because my A cannot just be 2 times 5. Can? So this will give me A to be 2 times 5 times 3, which is 30. And then for my B will be 2 cubed times 5, which will give me 40. Can? So the answer is 30 and 40. Then maybe can you try using another device? Or you try watch from the other device, see if you can hear me or not. Which part you want me to explain again? So LCM and HCF, you must understand what are they. HCF means all the numbers will have this at least these factors. So you can see initially I start off with 2 times 5 for both of them. Because all numbers must have at least the factors in highest common factor. Okay, then we look at the LCM, the lowest common multiple. It must come from one of the number. If not, it won't be in the lowest common multiple. Okay, so for LCM, we have 2 to the power of 3. So we look at the base 2 first. So one of the number from A or B must have this LCM of 2 to the power of 3. So let's say I put it in my B. I can't put in for both because if I put it from both, my HCF will not just be to the power of 1. It will be to the power of 3 already. Okay, so I put this power 3 in my, let's say I put it in my B. I will have the green highlighted parts now. Okay, so you can look at my LCM for the 5. It's already in my HCF. Okay, so now my A and B only have 5 to the power of 1, which also this is the same as the LCM. It can't be more than power 1. This is set 1 math. Okay, so now my LCM, what I'm lacking of is this factor, prime factor of 3. So it must come from either A or B, as it is not in my highest common factor. So it can only come from either of the number. So you think if it's better for you to put this factor 3 in your A or in your B? It can't be in your A, it can't be in your B because if I put this factor 3 in B, it will become 120, which is my LCM, and they tell you that this two number is not 10 and 120. And my A can't just be 2 times 5 because it will be 10 and it's not 10. It cannot be 10. So I have to multiply this 3 in my A. Okay, can understand how to split the factors? Can? Those who are done can move on to question 2. Yeah, this is set 1 math. Okay, for question 2, they give you these two numbers, 8,400 and 792. Okay, express each number as a product of its own prime factors in index notation. So in index notation means they want you to leave it in terms of base with its powers. Okay, so 8,400 can be divided by 2. We get 4,200 divided by 2 again, 2,100 divided by 2 again, 1,050. So 1,050, when you find the sum of the digits is 6, so 6 can be divided by 3. When we divide by 3, we have, oh wait, sorry, we divide by 2 first since it's still an even number. So we have 525, then we divide by 3. We get 175. The 175 can be divided by 5. We get 35. Then we can divide by 5 again. We get 7. Okay, until you get 1, then you stop that 1. And then all the factors at the side will be the prime factors. So 4,800 equals 2 to the power of 4 times 3 times 5 squared times 7. Okay, next we need to prime factorize 792. Divide by 2, we get 396. Divide by 2 again, we get 198. Divide by 2 again, we get 99. Divide by 3, 33. Divide by 3, we get 11. And divide by 11, we get 1. Yep, correct. 792 equals to 2 to the power of 3 times 3 squared times 11. Okay, so this is for part A. Yep, that's right. Part B is 24. They are asking for the greatest common factor. So for greatest common factor means they're asking for HCF. And to find HCF, we take the lowest power. Okay, so for part B, HCF of 8,400 and 792 equals to, since we are taking the lowest power, we have the base 2. 1 is to the power of 4, 1 is to the power of 3. So 3 is small, so we take to the power of 3. Times 1 is 3 to the power of 1, 1 is 3 to the power of 2. So I take 3 to the power of 1. So you can see that 792 don't have the prime factor of 5. So 5 to the power of 0 will be the lowest. So we omit 5. And then for 7, 792 don't have the factor 7. So Then same for 8,400, don't have the prime factor of 11. So we will skip all these numbers. So 2 to the power of 3 times 3, what we will have 24. Okay. So highest common factor, we take the lowest power. Part C, they're asking for lowest common multiple, so we take the highest power. Yep, that's right. So lowest common multiple of 8,400 and 792. So I take the highest power. The highest power of base 2 is 4. The highest power of base 3 is 2 times 5 square times 7 to the power of 1 times 11 to the power of 1. The life is around 1 hour. Okay, so you key in your calculator, you'll get 277,200. Part D, find the smallest integer value of n such that 8,400n is a perfect cube. So similarly, if you want it to be perfect cube means you want the powers to be multiples of 3. So 8,400n needs to be 2 to the power of 6 times 3 cube times 5 cube times 7 cube. So take note that we are multiplying by an integer, and so the number must be bigger, means the power must be at least the same or greater. So we'll find the nearest higher power of multiples of 3. Okay, and then we know that 8,400 is equals to 2 to the power 4 times 3 times 5 square times 7. We compare the powers here. So n must be 2 square. We take 6 minus 4 power 2. And then times for base 3 square. Sorry, 3 cube. This is cube, so cube minus 3 minus 1 is 2. So n needs 3 to the power of 2 times, same for 5. 5 the power is 3, then you minus power 2. So you get power 1 here. Then times for base 7, power 3 minus power 1, you get power 2. Okay, then you key this into your calculator and should be 8,820. Yep, that's correct. Well done. Part E, smallest integer value of k such that 792k is the perfect square. So perfect square means I want even powers, okay? No, part E is not correct. Take note that this is 792k. So it needs to have even powers, meaning it will be 2 to the power of 4 times, because the next even power will be 4 for 792. Then base 3 is already in power 2, even number, times 11. The base 11 is to the power of 1, so I need to make it to power 2. Yeah, they're asking for perfect square, so it has to be even numbers. Okay, therefore, if I know my 792 is 2 to the power of 3 times 3 squared times 11 to the power of 1, meaning my k needs to be 2 times 11 only. So k equals to 22. Okay, that's for my part E. For my part F and my part G, they are dividing by P and Q respectively. So we are trying to make the number smaller. So now instead of making the powers bigger, I have to make the powers smaller. What is the nearest one? Okay. So for part F, I have 8,400 over P. It needs to be, so to the power of 4 is already perfect square, it's even number for the power. Then times 3 to the power of 0 because 1 is an odd number. So I have to round up, make it small. 5 is square already, so I leave it. And then times 7 to the power of 0 because now it's power 1. Usually this kind is 1 mark per part. Only for the first one, part A will be 2 marks. Okay? So therefore my P has to be, you compare, you need to divide it by 3 and you have to divide it by 7. Therefore P needs to be 3 times 7. So that's for my part F. And then my part G, the smaller integer value Q for it to be a perfect cube. So same method, perfect cube, I want it to be, the powers to be in multiples of 3. So 792 divided by Q needs to be 2 to the power 3 times 3 to the power 0 times 11 to the power 0. Yep, Q is 99. Okay, so we compare it with 792. This one no changes, but I have to divide by 3 squared and 11. Therefore, my Q needs to be 3 squared times 11, which will give me 99. Because now it's power 1, we are looking at part F, right? Because now I'm dividing by P, so I can only reduce my powers, I cannot increase. So I remove it entirely means I have no more factors of 3 and 7. So which will leave me with just prime factors of 2 and 5 with even powers. Yep, correct. So multiply by 1 means no changes, right? It doesn't change the value. So can you see that this part here, because now I want it to be perfect square. So anything to the power of 0 is 1, right? Meaning this will give me 2 to the power of 4 times 5 square. Because this is like times 1 times 1 times 1 to anything, the value no changes. So that means we give the index 0 to odd numbers. No, it doesn't work that way. We give it to the only, sorry. Because can you see that this is power 1? We give it to the odd factors in this case. But if the power is 3, right, we only reduce it to power 2. And square would be perfect. So in this case, because it's power 1, we have to we have to go to the next nearest small that is smaller than 1, that is even number. That's why we reduce it to 0. However, if 3 is to the power of 3, right, we have to reduce it to 3 to the power of 2 to make it even. You get what I mean? This question, okay. So if you're looking at part A, right, it's around 2 marks. Then the rest is 1 mark each. So the whole thing itself is around 8 months. Okay? Because there's a lot of parts here. Can I move on to question 3? Written as a product of its prime factors, they give you the prime factors for 648 already. And they tell you that the number 648k is both a perfect square and a perfect cube. So it has to be, the powers of the prime factors must be even and multiples of 3. Meaning, yeah, this one needs to be even, this one needs to be multiples of 3. So what is the lowest common multiple of 2 and 3? It's 6. Therefore, actually my powers need to be in multiples of 6. Okay? So therefore my 648k, it has to be equals to, you can see that I'm multiplying with k, therefore my powers must be at least the same or greater. So you can see the power is 3 and 4. I want it to be multiples of 6, so I go to the nearest higher multiple of 6, which is 6 and 6. Okay, so my power 3, I change it to power 6. My power 4, I change it to power 6. Because my powers needs to be in multiples of 6. Then I see what should my k be. Then I subtract the powers. So my k needs to be 2 to the power of 3 times 3 to the power of 2. Which will give me 72. Okay, you just need to minus the powers. Yep, that's right. Because 3 times 2 is 6. That's why you want the powers to be in multiples of 6. Sorry, 6 is for which question? For question 3b, no, 6 is not correct. Because it has to be a number between 50 and 100. They tell you that x is the number between 50 and 100, and then the highest common factor of x and 84 is 6. Find the smallest possible value of x. Means 6 is a factor of x. Okay, technically what you want is x must be a multiple of 6. That is between 50 and 100. And they tell you that the highest common factor of x and 84 is 6. So for the smallest possible value of x will be, what is just greater than 50 and is a multiple of 6? Yep, 54 is correct. So therefore the answer has to be 54. Okay. Then you can see 54 is 2 times 3 cubed. And then 84 is 2 square times 3 times 7. You have to make sure that your highest common factor is just 6. Okay. So you can see that the HCF will comes from here, 3 to the power of 1, because 6 equals to 2 times 3. So you can see that the lowest power of their bases will be 2 to the power of 1 and times 3 to the power of 1. So 54 is correct. Sorry, which part? Why? Can? Yep, correct. 1.4 minutes. You can leave it in decimal also. How is it like that? Because the highest common factor of x and 84 is 6, right? It means 6 is a factor of x, correct? X must have this factor 6. And then when you reverse it, it also means x must be a multiple of 6. And they want it to be between this number, 15 and 100. And they want it to be the smallest possible. Okay, so the smallest multiple of 6 that is between 50 and 100 is 54, correct? Okay. Part C. Two toy cars race around a circuit of equal-sized tracks. They take 12 seconds and 21 seconds respectively to complete one round of the track. Given that the cars leave at the starting point on each track at the same time, how long will it take in minutes before they are at the starting point together again? So this quite this, okay, quite similar to those that you have learned in primary 4. So technically what you want to find is the lowest common multiple. So 12 is equals to 2 square times 3. And then 21 is equals to 3 times 7. So you find the LCM by taking the highest power here. So highest power of base 2 is 2 times highest power of 3 is 1 times highest power of 7 is 1. So therefore my LCM is 84. Take note it's in terms of seconds. Sorry, there's typo here. 84 seconds. When I convert it to minutes, it should be 1.4 minutes. Okay. Anyone has any question here? Those are done can move on to question 4. Can I move on to question 4 now? Yep, that's right. Good job. Two numbers A and B written as the product of their prime factors are as follows. Find the largest integer which is a factor of both A and B, leaving your answer as a product of its prime factors. So this what they're trying to say is they're asking you to find the highest common factor. Okay. So for highest common factor, we will take the lowest power. So when we compare the base to the lowest power is 2 power 3. And then when we compare the base 3, the lowest power is power 8. So for 5 and 7, since none of them they do not have, means the lowest power is 0. Integer means something like whole numbers. They cannot have any decimals. Yep, kind of. Because they're asking for the largest integer, so you can try to relate largest with like highest. That's why they're asking you to find the highest common factor. they say leave in the as a product of its prime factor, so we just leave it as it is in index notation. Sorry, for which part? They want the largest integer, which is a factor of both a and b. It means they want you to find the highest common factor between the two numbers. Because factor, can you see the factor word here? Largest means highest. Oh, because HCF, we are always taking the lowest power. Remember? For LCM, we always take the highest power. For HCF, we always take the lowest power because we want something that is in common. So this one have at least 2 power 3, right? For A, is here, A we have 2 power 3, B we have 2 power 6. So the lowest power is 3, right? So to find HCF, we take the lowest power here. Then for base 3, when we're comparing base 3, we have 3 power 8 and 3 power 12. So 3 power 8 is the lowest power. That's why we take 3 power 8. Then for 5, this is 5 to the power of 1. If there is no factor of 5, means it's to the power of 0. That's why I will choose 5 to the power of 0 for this because this is the lowest power. Technically, I don't have to write because it's just multiplied by 1. Then same for the 7. If don't have 7 means times 7 to the power of 0. And then this is times 7 to the power of 1. You're right. Because part B they're asking for. For part B is you need all the factors of B. Okay. B they're not asking you for the lowest common multiple. They're asking you to find the value of k. So find the smallest integer k such that a times k is a multiple of b. So in order for your a times k to be a multiple of b, you must have all the factors of b. You're finding k only, you're not finding a times k. K, take note here. And then you know that your a is equals to 2 power 3 times 3 times 3 power 12 times 5. So this means my a times k is my LCM. Yep, it ends at around 9 if there's no delay. Okay, so a times k is my LCM. LCM means I take the highest power. So when I compare them, the highest power for base 2 will be 6. For base 3 will be 12. For base 5 will be 1. And for base 7 will be 1. So this is my lowest common multiple. I take the highest power. Then the tricky part is here. They're asking for the value of k. The factors here comprises of the factors of a. So we have to subtract the power. So for base 2, 6 minus 3, the power is 3. 3 to the power of 12 comes from a already, so we don't need. Same for 5, 5 to the power of 1, so we just need 2 cubed times 7. You can just write 5. 5 equals to 5 to the power of 1. They are the same thing. Okay, so 2 cubed times 7 will give me 56. So K is the 56. Can understand? Okay. Let me know if you have any question here. Okay, for smallest integer k such that a times k is a multiple of a, right? Multiple of b. Multiple of b means I need all the factors in b. And I want this a times k, I want k to be smallest integer, means I want this to be as small as possible. So this means my a times k is the LCM of a and b. Because there is a here, and it has to be a multiple of b, whereby I need all factors of b. So this means I'm finding the LCM. And then to find LCM, I will take the highest power of all the base. Perfect square just means that my power for all the prime factors are even numbers. Okay, so a times k, which is my LCM of a and b, I need to take the highest power of the prime factors of a and b, which will give me to the power of 6, because for the base 2, cube is all multiple of 3. So 2 to the power of 6, because 6 is the highest power. Then for base 3, 12 is my highest power. You can compare here. So 6 is my highest power, 12 is my highest power, 1 is my highest power for 5 and 7. Yes, that's right. You choose the number with highest power for LCM. Can? No, there's no Kahoot for today's live. Can I move on to part C? Find the smallest integer p such that a times p is a perfect square. So same thing, perfect square means I want the power is a multiple of 2 or even powers. Okay, so I know that my a is 2 to the power of 3 times 3 to the power of 12 times 5. So a times p must be, since it's multiplied by p, so my a times p must be a greater value than a. Okay, so I will round, either maintain my powers or I round up to the nearest even number. So now my power of 2 is 3. It's not an even number, so I have to round up to 4. Okay, then for base 3, my power is 12. It's an even number also already, so I just leave it. Then for 5, now it's 1, so I have to go to 2. Okay. So with this, we can compare a and a times p to find what are the values of p. Technically, we can take a times p divided by a, whereby we subtract the power. So for base 2, power 4 minus minus 3, we get 1. 3 to the power of 12 minus, power of 12 minus power of 12 is nothing. So if the power is an odd number, if it's an odd number, then we have to make it even. Yes. But if we are dividing by a number, right, then we have to minus 1 instead of adding 1. Because in this case, we are multiplying by p. Yep, correct. So if it's 1, right, we have to plus 1 to make it even number. Can see that? Hmm? It means 0, huh? If it's 0, then it's not, there's no factors, nah. So it means my p is 2 to the power of 1 times 5 to the power of 1. So what will you need for p? You can just subtract the powers to find what you need. Yep, for all the prime factors, you require an even index number. The power needs to be even number if it's a square number. Therefore, my p is equals to 10. Can? Okay, can I move on to question 5? In the museum, 3 antique clocks will chime at regular intervals of 10 minutes, 12 minutes, and 3 minutes. If they chime together at 6 a.m. and at 11 a.m. in the morning, find the smallest value of t. So from 6 a.m. to 11 a.m., it is 5 hours. You can take note here that they are all in terms of minutes, so I have to convert this 5 hours to minutes. Yep, 25 is correct. So I multiply by 60 to convert to minutes. And this is the LCM. LCM is 300. I prime factorize this 300. I'll get 2 square times 3 times 5 square. Okay, so this is my lowest common multiple. The intervals is 10 minutes and 12 minutes. So I find the respective prime factors first. 10 is 2 times 5. And 12 is 2 square times 3. They want the smallest value of t. So as much as possible, try not to give t any factors unless needed in order for it to be the smallest. Okay, so you look at the LCM. LCM must come from somewhere. So this 2 square can come from 12. And then this 3 comes from 12 also. But 5 square doesn't come from any of the number here. So it has to come from t. That's why my t, the smallest value of t has to be 5 square, which is 25. Anyone done with question 6? Because for LCM, remember you take the highest powers, correct? So the highest powers must come from somewhere. If it doesn't come from 10, it doesn't come from 12, it has to come from T. Sorry? Okay, you look at the base 2 first. This 2 square, right? It can come from the highest power of this number 12, correct? Remember LCM, you take the highest power. So this highest power comes from this 12 for my base 2 power 2. Then for my this 3 power 1, it can come from this 12 also. Can see that? That's why my T doesn't need to have 2 square and 3 power 1. But in order for me to have LCM of 5 square, as it's one of its prime factors, it must come from somewhere. If it's not from 10 and 12, it has to come from T. Okay? Okay, we look at last question, question 6. A closed cubic tank has the capacity to hold 13,824 cubic centimeter of water. It is made out of glass that is 1.2 cm thick. Calculate the volume of glass required to make the tank. So, we prime factorize this number. We will get 2 to the power of 9 times 3 to the power of 3. So after having this prime factorization of the number, it's a cubic tank, so we can find what is the length. Firstly, we can find the inner length first. Inner length means I exclude the thickness of the glass. So I just need to divide my powers by 3, since it's cubic. So I have 2 power 3 times 3 power 1. I divide the powers by 3. So that my length times breadth times height will give me 2 power 9 times 3 power 3. So if this is the inner length, they tell you that the glass is of 1.2 cm thick. So I have to add the left and right side. That's why I have to add 2 times. So the length of cubic tank will be 2 power 3 times 3 power 1 plus 1.2 cm thick on both sides. Okay, then this is equals to 26.4 cm. So this is the length of the cubic tank. Calculate the volume of glass required to make the tank. So the dimensions will be, the dimensions of the glass will be 26.4 cm by 26.4 cm by 20. I divide the power by 3. Because it's a cubic tank. Remember, volume of cubic tank is length times length times length. Is the prime factorization of 13,824. Yep, correct. You have to prime factorize it. Can? So the volume of glass required to make the tank would be 26.4 cm times, so length times length times length. Don't forget to minus away the inner capacity, which is the capacity of the tank. Okay, then you get 4,575.744 cubic centimeter. And because the inside doesn't have the glass, so you have to minus away the space. Is everyone done with this question? So for those who are interested, you all can join our free trial. There's a free trial for the online class. So for Sec 1 will be on Saturday. I'm teaching Sec 1 Math and Sec 2 Math for the online class. Because it's 3 dimension, remember? For cubic tank is length times length times length, right? That's why we divide the power by 3. Okay. The next TikTok live will be tomorrow for, let me see. Tomorrow is primary 6 math, 7 p.m. 1.2 is the thickness of the glass. Because when they are talking about the capacity, they are talking about the space inside the glass, excluding the thickness of the glass. For Sec 1 math will be 2 weeks later. Because 2 sides, right? Try to imagine how does the tank look like. This is the inner space. So there is 2 sides to this 1.2. So you have to add 2 times. And it cannot see. Yeah? Can see? Can see the diagram? No, because when you view the whole tank itself, right? There's 2 sides to the thickness. Can you visualize the tank? Yep, correct. That's why you add it inside. You're finding the length of the whole glass. Because you're finding the volume. So volume is length times length times length. Yes, cubic tank have the same height, same length, and same. All of them are the same. That's why we just use length times length times length. Yep, correct. because we are finding the volume of the glass only. Inside is empty. Or rather, it's water, it's not the glass. Can? Any other questions? So those who want to join our free trial can contact us. For Sec 1 Math will be on Saturday. If there's no other question, I'll end the live here. See you next live.